So far we've looked at DDoS attacks in a fairly basic fashion. We've just talked about volumes of traffic, and indeed in the Loic example it was just simple HTTP requests. But DDoS does get much more sophisticated than that, and attackers are always looking for ways to make their attacks more effective. So for example, they'll try things like an amplification attack. And what they're trying to do here is make a request that then generates a larger response. Now, one way of doing that might be to request resources that, say, return very large documents from the target website. That's going to be more effective at flooding the outbound connection than, say, requesting a very efficient, lightweight page. Another example that has a bit of a twist in it is a DNS reflection attack. And in this example, the attacker is going to make DNS queries. But in that query, they're going to forge the originating IP address such that the response to the query is sent to the target website rather than going back to the attacker. So this is the reflection component. The attack is actually reflected back from the DNS servers to the target website. It can also be amplified by making the right DNS request such that those responses are as large as possible. Distribute that out to enough DNS servers and make enough requests, and it can be enormously effective as that amplification effectively gears the response up and creates greater impact. Another one again is an NTP attack. So this is the network time protocol, and it's another reflected attack. And it uses spoofed packets sent via UDP, which then cause the response to go back to that target website. And we're seeing a lot of different DDoS attacks that are exploiting different protocols in order to impact the target website in all new ways. Another example of that would be an SNMP attack. So this is the Simple Network Management Protocol. And you'll often see that used in the management of things like routers or servers or printers, IP video cameras. And just one more example to show the diversity of different attacks, a SYN flood attack. Now I talked a lot about SYN packets in the TCP connection in my ethical hacking session hijacking course. And this now becomes an attack at the TCP layer. So it's a different attack again targeting a different protocol. And it just goes to show how diverse these attacks are. This is just a small sample. There are many, many different types of DDoS attack beyond these 5 here. The point I want to make though is how diverse DDoS attacks are. Not just in terms of where they originate from or what the tools are, but indeed how they're constructed and what sort of protocol it uses. And this is in part why they remain so prevalent, because they keep evolving. Now all that then begs the question, how do we mitigate against the risk of a DDoS attack? So how can you protect an application when there could be literally thousands of machines out there targeting your web app, and you have to somehow keep that malicious traffic out and still serve the legitimate traffic? Let's look at a few ways now. Defending against DDoS attacks can be enormously tricky, and particularly as those DDoS attacks not only get larger, and certainly we are seeing them get much larger over time, but also get more sophisticated. Well, one option, and this is very much the traditional approach, is perimeter defenses. So network infrastructure that sits in front of the target web application that's designed to keep malicious packets out and good packets in. Certainly there is a place for that, but it's difficult to stay on top of continually evolving attacks that are exploiting all new ways of sending huge volumes of traffic to the target web application. These devices can certainly be expensive as well. Network infrastructure designed to deal with large volumes of traffic can carry a pretty hefty price tag. An alternative to that is DDoS mitigation as a service. And I'm going to give you an example of that on the next slide. But this is where you get DDoS mitigation as you'd get in a traditional perimeter defense model, but somebody else provides it, and they provide it as a managed service that sits in front of the web application. We'll take a look at that a bit more closely in just a moment. Of course, another option is simply blocking incoming sources of traffic. Now that's partly what the previous 2 points do. They'll certainly a point where they'll simply block the traffic from particular origins. But it's also difficult, particularly in a distributed denial of service attack, to identify which are the legitimate hosts and which are the malicious hosts. Basing it on, say, IP address is difficult, particularly when it could be spread out over thousands of different machines. The smarter DDoS defense implementations do start to look at pattern-based behavior. So what does good traffic look like? And then consequently, if the traffic doesn't comply to that, might it be bad traffic? It obviously gets more sophisticated, but it also gets much more effective. Then there's the old adage of beat it with bandwidth. If your bandwidth is big enough, it may be that you can simply weather the storm of a DDoS attack. Yes, it's a huge volume of traffic coming in, but you've got the bandwidth to support it. If the attackers aren't able to have an impact on the service, eventually they'll give up and move on to something else. That can be a bit of an arms race though, as the defender keeps adding capacity and at the same time the attackers get smarter and increase the volume of the attacks. Certainly that should be part of the strategy, and that does give you a good buffer, gives you some insurance against when these attacks come in, but it has to be part of a broader strategy. And one other final point on this. We've seen many examples where the DDoS is a diversion technique. Now what I mean by that is that whilst engineers are busy trying to respond to a DDoS attack, the attackers are mounting the actual attack that they wanted to mount. Perhaps it's a SQL injection attack where they're exfiltrating data from the website. Or maybe they've managed to get RDP sessions in behind the firewall. Again, there are many precedents of this. We've seen multiple occasions where alongside a DDoS attack, there's actually been an attack that does actually access sensitive data. And let me also be clear about this. DDoS attacks don't typically impact the integrity of the system. So they don't cause data to be leaked, they don't circumvent access controls, they don't do any of the other things that we've seen throughout this course. They simply make the service unavailable to other people. Now I mentioned DDoS mitigation as a service. Let me give you an example of that. I want to talk briefly about the Cloudflare model. And I'm talking about Cloudflare because I have another course on Pluralsight called Getting Started with Cloudflare Security. And it's all about how you can get their service set up as a protection for your web application. Now here's the way Cloudflare describe their service. Most of the time, a web application is naked. And what they mean by that is that all these three sources of requests, so visitors, crawlers and bots, and attackers, are going direct to the site. The site has no defense in front of it, therefore it is naked. Now what the Cloudflare model does is it routes all of the traffic through their infrastructure. And by doing that, they can let through the crawlers and bots because you do still want search engines to crawl and index your site, but then they can block the attackers. And the really neat thing about the Cloudflare model is that because they protect such a significant portion of the internet, they're one of the world's largest web assets, they can build up a very comprehensive profile of what malicious traffic looks like. Now that malicious traffic may not be going to your site now, but they can observe it on other sites. And if it does come to your site in the future, then they can block it appropriately. They also make this model available for free. There are commercial offerings that give you more features, but you can wrap Cloudflare around a web application and get DDoS defense straight out of the box in mere minutes without spending a cent. When you do move up the pricing tiers, particularly as you start to protect larger and larger assets, the ability to delegate DDoS protection to a provider like Cloudflare, rather than standing up that dedicated infrastructure and handling attacks yourself, can be very attractive to organizations. So that's a bunch of different ways of defending against DDoS attacks. That brings us to the end of this module. Let's go and take a look at the summary.